Hello folks, so in this video I wanted to just talk about where we find the removal discontinuity, and more specifically how we get its y coordinate. So this is an example that we did in class, so we've already gone through most of it. We found the vertical asymptote, and we know that the horizontal asymptote is, as usual, at y equals 0. Okay, and we also know where the removal discontinuity is, so let's just take a second here and review where we know that, or how we know that. So again, to find the removable discontinuity, you're looking at the x values that are going to give you a 0 over 0 output, an indeterminate output, as we say. We can see here, the only times that's going to happen is if we plug in 1/3. So we'll just prove a concept that f of 1/3 is going to be, well, let's see, 3 times 1/3 is going to be 1, minus 1 is going to give you 0. So you get 0 over 1/3 plus 2 times 0, which again is going to equal 0 over 0. Okay, so the fact that we end up with 0 over 0 in this rational function is evidence that we are going to have a removable discontinuity at x equals 1/3. But remember, what is a removable discontinuity? It's simply a hole in the graph. And so the thing I'm curious about is, well, that's a point that is simply erased or plucked out of there. So what is it? Like, what is the actual point? Meaning, we know its x value, but what's its y value? So how would I do that? Well, remember, this is where we want to compare the function to a simplified version of the function. So I'm going to sketch that over here. So this function over here is f of x is equal to 3x minus 1 over x plus 2, 3x minus 1. The red one that I'm going to draw is over here. I'll call it g of x, and it's very similar to the first function f, is if I cancel out, oops, sorry, my head's in the way, if I cancel out the 3x minus 1s. But we know what this one looks like. This one's a lot easier to draw. I'll draw right here. I'll try to draw it roughly the same size as the first one. Something like that. And so we know our asymptote is going to happen at -2, just like that. So I'll draw that one right there. And that's going to be like this. Okay, so remember, these graphs are near identical. The only difference is that in f, you cannot plug in 1/3, x equals 1/3, because it's not in the domain, because you'll divide by 0. Now, here's the question, is where is that corresponding point on the red graph, g? Well, that's not so hard to find, because we know how to find it. I know that the x value is 1/3, and the output, the y value, is going to be just g of 1/3, 1/3. And so if I check that, well, g of 1/3 is, let's see, g of 1/3 is going to be 1 over 1/3 plus 2. If I work this out, I should end up with 3 over 7. And so the removable discontinuity, the purple graph, the hole in the purple graph, is simply that point, the red one, plucked out. And so this is how we find the y value of the removable discontinuity. You simply find the x value by finding where you get 0 over 0, and then plug that into the simplified equation to find what the y value kind of should be, or what it was supposed to be. And so we know that this graph, or this removable discontinuity, is actually at 1/3, comma, 3 over 7. So hopefully that clarifies that if you were unsure of how to find it before. Thanks for watching. Stay spicy, folks.